Hey, my third grade mathematicians. Today we're going to continue to work on fractions. We are going to recognize and show that equivalent fractions have the same size, though not necessarily the same shape. Also, remember today you're going to be looking for the mystery word. And this is a word that you might hear several times throughout the video. And I'm not going to tell you that it's the mystery word. You're going to have to figure out what word that I use a lot throughout the video to help you to learn about this lesson today. So let's begin with our problem of the day. You have the problem of the day in your packet, so make sure you turn to that problem of the day. And it says application problem on yours. So let's begin by reading this together. Everyone ready, read. Max ate 2/3 of his pizza for lunch. He wanted to eat a small snack in the afternoon, so he cut the leftover pizza in half and ate one slice. How much of the pizza was left? Draw a picture to help you think about the pizza. So let's start out. We read. Now let's make sure that we underline and circle what is important. So tell a friend, what's important in this story? Yes, it is important that Max ate 2/3 of his pizza for lunch. So I'm going to start out, and I want you to as well, to draw Max's pizza. So go ahead and draw that. And it says that he ate 2/3. If he ate 2/3, how many equal parts does this pizza have? Very good. It has 3 equal parts because the denominator is 3. So I put a little dot in the center to help me to draw these 3 equal parts and make sure that each part is the same. Now he ate 2/3, so we're going to shade in 2/3 of this pizza. So I'm going to do that now. So there's 1/3. And now I have shaded in 2/3 of this pizza. Let's keep going. What else is important? Oh yeah, he wanted a small snack, so he cut the leftover pizza in half and ate one slice. So I'm going to change the ink colors. It says that he cut it in half. Well, if I cut this leftover piece in half, do I now have equal pieces all around my pizza? No. So I'm going to have to cut this part in half and this part in half. Now, what is how many equal parts do I have? Right, I have 6 equal parts now. So it said that he ate one slice, so he's going to eat this slice right here. So we have to figure out how much of the pizza was left. Very good. There's 1 out of 6 pieces left. So I can write my sentence and say 1/6 of the pizza is left. Remember, it's very important for you to read, draw, and write. Okay, let's keep going. Good job, boys and girls. So, as I said, we're learning to recognize and show that equivalent fractions have the same size, though not necessarily the same shape. So let's begin with Model 1. If you'll look at my Model 1 right here, the whole is all of the cubes. So all of the cubes is the whole. Tell a partner what fraction of the cubes are blue. Very good. 1/4 of the cubes are blue. So there's 1 blue one, and there are 4 altogether, so 4 out of 1. Now let's look at Model 2. Here we have Model 2. The whole is all of the cubes again. Now tell your partner what fraction of these cubes are blue. Yeah, they're both the same. 1/4 of these are blue as well. So talk with your partner. Is the fraction of cubes that are blue in these models equal or equivalent, even though the models are not the same shape? Very good. The units make a different shape in the second model. It's square rather than rectangular, but they still show the same fraction because there's 1 blue out of 4. There's 1 blue out of 4. So the size of the units and size of the whole didn't change. That means that 1/4 and 1/4 are equal, and we call these equivalent fractions, even though the shapes of our whole are different. Very good job. So now I've added another model. Now we have model 3. So take a look at model 3. What fraction of model 3 is shaded in? Very good. 2/4 of model 3 is shaded in. But how much of model 1 is shaded in? Right, 1/4. And what about model 2? 1/4 there as well. So why aren't these two fractions equivalent? Right, the blue covers more area in model 3. 2/4 of the square is shaded in, whereas in models 1 and 2, only 1/4 is shaded in. When we're finding equivalent fractions, the shapes of the wholes can be different. But equivalent fractions must describe parts of the whole that are the same size. So in model 3, the parts of the whole are not the same size as model 1 and model 2. Model 1 and model 2 are equivalent, but model 3 is not equivalent with those two models. All right, look at my picture. I want you to write on your paper the fraction that is shaded. So how many parts are shaded in? 1, 2, 3. 3 parts are shaded in. How many parts are there total? 1, 2, 3, 4, 5, 6, 7. So 3/7 of this model is shaded in. Now what we're going to do is we're going to draw another representation of the same fractional amount. Remember, the units have to be the same size, and we're going to make them the same shape, but the entire polygon can be a different shape. So I'm going to start out, and I'm going to make my representation. So that would be 1 unit, and it's about the same size as that one. 2, 3, 4, 5, 6, 7. Now I have to shade in 3 parts. So 1, 2, 3. So I have shaded in 3/7 of this rectangle. Did I cover the same area in both of these? Do both of these represent 3/7? Yes, they do. Now, if I had drawn it this way and said, okay, 1, 2, 3, 4, 5, 6, 7, and shaded those in, do they show 3/7? No, why not? Very good. The units are much larger in this one than they are in these two. So the units must be the same size. Way to go. Excellent job. Okay, let's look at this. These two shapes both show 4/5. If you look at this one, there's 1, 2, 3, 4 of 5 shaded in. In this one, we have 1, 2, 3, 4, 5, and 4 shaded in. Are the shapes equivalent? Why are they not equivalent? Right, they're not equivalent because the units are not the same size. So the shapes are not equivalent. So you need to answer it in a complete sentence. The shapes are not equivalent, and then I want you to explain why on your paper. You can pause the video while you do that. You can say I know or because, but you need to finish that and tell why they're not equivalent. Now, I also want you to draw another representation that shows 4/5 and make it equivalent here. So I'm going to do one showing 4/5. So there's 1, 2, 3, 4, 5, and I'm going to shade in 4. So that's 4/5, and that's equivalent to the first shape. Now you can also do one for the second shape, and I want you to do that by yourself as well. You can pause the video while you do that. Now, guided practice. Let's look at this. What is the fractional? What is the shaded part for this fraction? Okay, there's 1, 2, 3, 4, 5 parts shaded in. And then I know there's 3, 6, 9, 10, 11. So 5/11 is shaded in. Now you need to draw a new picture representing 5/11. Now let's also look at this one. How many parts are shaded in? 1, 2. Now how many parts are there altogether? What's the fractional unit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2/10 is shaded in on that one. I'm going to draw a representation of 2/10 for this one. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's close. It's not great, but it's close. Okay, and then I'm going to shade in 2 of those. So that would be an equivalent representation, close to equivalent. Okay, now at the bottom, label what fraction of the figure is shaded. So we have, how much is shaded in this one? 1, 2, 3, 1, 2, 3, 4, 5, 3/5. Okay, do the same thing on this one. 3 shaded in, and 1, 2, 3, 4, 5. So 3/5 on that one. Let's do this one. 1, 2, 1, 2, 3, 4, 5, 2/5. And the last one, 1, 2, 3, and 1, 2, 3, 4, 5, 3/5. Now circle the fractions that are equivalent. Very good. This one, and this one are equivalent. This one is not equivalent with the rest because it does not cover the same amount of area. Great job. All right, so today you are going to complete Lesson 20 problem set. You're going to complete all of the front, and I did the first one for you. And on the back, I want you to choose either number 3 or number 4. Text me what you think the mystery word was today. A very important word that you heard several times throughout the video. Text me or call me if you need me.